Imagine looking up at the night sky and realizing that somewhere out there, a planet is literally being devoured by the star it orbits. This isn't a scene from a science fiction movie or a theoretical model anymore. It's real. For the first time in history, the James Webb Space Telescope has captured a planet in the final moments of its existence, as it is being swallowed by its host star. And the results have shocked even the most seasoned astronomers. In a distant corner of our galaxy, roughly 12,000 light-years away from Earth, a solar system has become the stage for one of the most violent cosmic events ever witnessed. The star at the center of this system, a bloated, aging giant nearing the end of its life cycle, has expanded to such an extent that it has started pulling in the closest orbiting planet. And in a moment that has left scientists both stunned and excited, the James Webb Space Telescope captured clear evidence of this planetary death in progress. Now you might wonder, why is this such a big deal? After all, we've known for a long time that stars can consume their planets when they become red giants. Our own sun is expected to do the same in about 5 billion years. But until now, this process has never been directly observed. It has always been theoretical, something we understood through simulations and indirect evidence. What Webb has given us is a front-row seat to the kind of cataclysm that reshapes entire solar systems. The images and data collected by the James Webb Space Telescope are both haunting and awe-inspiring. Using its powerful infrared sensors, Webb detected a sudden burst of heat and light coming from the planet-star system. Initially, astronomers thought this might be a supernova or some other kind of stellar explosion. But as they looked deeper, they realized the signature was something else entirely. Evidence of a planet's atmosphere being stripped away, layer by layer, and pulled into the star's fiery envelope. What makes this observation even more astonishing is that it wasn't just destruction. Alongside the expected collapse of the planet, Webb picked up unusual chemical signatures in the surrounding space. These chemical traces weren't what scientists anticipated. Instead of just carbon, hydrogen, and helium, they found unexpected concentrations of heavy elements like magnesium and iron. These readings suggest that the dying planet may have had a metallic core, something like Earth or Mercury, and that this core was being torn apart and vaporized by the star's immense heat. This planetary consumption event has opened up an entirely new chapter in our understanding of how stars and planets interact, especially in the final stages of a star's life. It's not just a dramatic end, it's a chemical and energetic transformation that can seed surrounding space with elements essential to the birth of new planets. That means this violent death could contribute to new beginnings elsewhere in the cosmos. And then there's the matter of the unexpected results. Astronomers were surprised to find that the star itself dimmed temporarily after consuming part of the planet. This was not something predicted by existing models. The prevailing assumption was that the star's brightness would increase as it gained new material. But instead, the opposite happened. Scientists now think this dimming occurred because the debris cloud from the consumed planet temporarily blocked the star's light, similar to how a dust storm can obscure the sun here on Earth. Even more curious was the detection of a magnetic field disturbance around the star. The planet's core, likely rich in iron and nickel, may have disrupted the star's magnetosphere as it fell inward. Such an effect has never been seen before. It hints at a complex interplay between a planet's structure and a star's magnetic activity, an area of research that will now likely explode with interest. These findings are important not just for what they tell us about distant solar systems, but for what they suggest about our own. Our sun, too, will eventually expand into a red giant. Earth may be far enough away to escape immediate destruction, but Mercury and Venus certainly aren't. Watching this planetary death unfold in real time gives us a preview of our solar system's future, a kind of cosmic mirror that reflects what might lie ahead. So, how exactly did the James Webb Space Telescope capture such a precise and rare moment in cosmic history? The answer lies in its advanced infrared capabilities. Unlike visible light telescopes, Webb can detect heat signatures that reveal the movement and composition of objects obscured by dust or distance. It wasn't just a lucky snapshot, it was the result of months of focused observation, targeted at a star system already showing signs of instability. As the telescope honed in on this aging star, scientists noticed a strange anomaly, a fluctuation in its brightness that didn't match typical stellar behavior. That's when they decided to train Webb's instruments on it, collecting high-resolution data over several nights. The infrared readings began to show irregular patterns of heat, indicating something large was being vaporized. Slowly, the picture became clear. A planet, likely a gas giant similar to Jupiter but closer to its star, was in the process of being consumed. The visuals are surreal. You can imagine the planet being stretched like taffy, its atmosphere peeling away in layers as gravity pulls it toward the star. The outer clouds of gas begin to spiral inward, creating a glowing trail of material. As the planet disintegrates, what remains is a glowing shell of metal and rock that finally succumbs to the overwhelming force of its parent star. It's a process that happens over weeks or months, but Webb has captured snapshots that let us see it in stages, as if time itself slowed down for us to witness this cosmic drama. What's equally remarkable is the way scientists were able to analyze the planet's composition from this distance. Using spectroscopy, Webb measured how different elements absorbed and emitted light. This technique revealed that the planet had a complex structure, with layers of gas surrounding a dense metallic core. The composition was similar in some ways to Earth's, but with notable differences, particularly in the levels of rare elements like vanadium and chromium, which suggest geological activity and differentiation during the planet's lifetime. As the story of this dying planet unfolds, it challenges many of our assumptions about planetary systems. It raises new questions. How common is this type of event? Could there be remnants of other planets already consumed by stars that we've never noticed? What happens to the debris? Is it absorbed entirely, or does it form rings or even new planets over time? Scientists are now combing through Webb's data to find answers. And what they're learning is that the universe is far more dynamic and violent than we often imagine. It's a place where planets can die, stars can change their nature, and cosmic forces interact in ways we're only beginning to understand. And this is just the beginning. In Part 2, we'll explore how this discovery is reshaping the way we think about star-planet relationships, what this could mean for the search for life elsewhere in the universe, and how the James Webb Space Telescope continues to push the boundaries of what we know about the cosmos. As the James Webb Space Telescope continued to observe the incredible event of a planet being consumed by its host star, scientists began to uncover even more astonishing details. What initially seemed like a straightforward case of stellar destruction gradually turned into something much more complex. The precision and depth of Webb's instruments brought forward a series of anomalies, unusual data that simply couldn't be explained by existing models. It appeared that this was not just the story of a planet dying, but a mystery unfolding in real time, one that challenged how we understand planetary systems and stellar life cycles. The first major surprise came from the composition of the material being ejected as the star swallowed the planet. Normally, when a gas giant is consumed, you'd expect the cloud of debris to show large amounts of hydrogen and helium, its most abundant elements. But Webb detected something else. Mixed within the gas cloud were high concentrations of heavier elements, such as silicon, iron, and even traces of water vapor. This suggested that the planet might not have been a typical gas giant, but possibly a hybrid world, something with a rocky or metallic core that survived deep into the planet's final moments before being shredded apart. This immediately raised questions. Was this planet more Earth-like than we originally thought? Could it have supported moons, atmospheres, or perhaps life? Adding to the mystery was the strange pulsing of light observed around the star during the final stages of the planet's destruction. Astronomers saw periodic dimming and brightening, not consistent with a simple ingestion process. Instead, it looked like the star was reacting, almost spasming, as it absorbed parts of the planet. Some theorists suggested that the infalling material may have momentarily disturbed the star's magnetic field or surface layers, causing temporary fluctuations. Others speculated something even more dramatic. Was it possible that the planet's core caused a brief fusion-like reaction or energy burst as it fell into the stellar envelope? These were unprecedented ideas, but the data from Webb hinted that we might need to rethink what really happens in the final moments of a dying planet. Another fascinating detail emerged from the infrared imaging. As the planet was being torn apart, Webb noticed an unexpected trail, a long glowing arc of dust and gas stretching far from the star. At first, this arc was assumed to be normal stellar ejecta, but the more scientists analyzed it, the stranger it seemed. It was too cold, too structured, and oddly symmetrical. Some even likened it to a massive tail, similar to what you might see on a comet but much larger. This raised an exciting theory. Perhaps this planet didn't fall directly into the star. Maybe it was orbiting in a decaying spiral, shedding its outer layers gradually, until the final plunge. This meant that Webb might have captured not just a moment of destruction, but the entire slow-motion death spiral of a doomed world. These visuals, bright flares, flickering shadows, and a majestic trail, were not only scientifically rich but emotionally stirring. For many astronomers, this was the first time they had truly seen a planetary death unfold, not just through simulation or theory but in reality. It brought a new perspective to the fragility of planetary systems. Our own Earth, nestled safely in the habitable zone for now, may one day face a similar fate when the sun expands into a red giant billions of years from now. And while that's far in the future, Webb's observations are a haunting preview of what's to come, not just for our planet, but for countless others across the galaxy. Perhaps the most chilling takeaway was that this planet had once likely been in a stable orbit. Its star hadn't shown signs of immediate instability. What changed? Why did its orbit decay? Some scientists believe that gravitational interactions with another hidden planet in the system may have destabilized it, sending it inward over time. Others point to tidal forces or even stellar mass loss as potential causes. But whatever the trigger, the planet's descent was slow, silent, and unstoppable. And it was this very gradual fall that allowed Webb to witness the entire process, from the first signs of orbital decay to the fiery final moment when the planet vanished into the star. And yet, amidst the destruction, there was beauty. The glow of heated gases, the sweeping arc of ejected matter, and the final flicker of light where the planet once was, all captured in stunning detail by the Webb telescope, formed a celestial ballet of creation and loss. Artists and astrophysicists alike were captivated. For every image that Webb transmitted, there was a flurry of excitement across social media, research labs, and even classrooms. The public was fascinated by the idea that we were seeing a cosmic moment that had never been directly observed before, a true first in human history. But the implications go beyond awe. Understanding how planets die gives us crucial insight into how planetary systems evolve. It tells us about the stability of orbits, the longevity of exoplanets, and even helps us refine our search for habitable worlds. If we can identify which planets are likely to be ejected or consumed, we can narrow our focus to those with longer, stable lifespans. And that could be the difference between discovering a barren rock or a thriving alien ecosystem. Moreover, this event provided an unexpected opportunity to test new models of stellar behavior. The ingestion of a planet deposits material, angular momentum, and energy into a star. This can affect its rotation, brightness, and future evolution. Already, some models are being revised to account for these findings. The event Webb captured may serve as a benchmark for future simulations, helping astronomers predict what might happen in other similar systems. It's the kind of real-world data that textbooks will use for decades. Another surprise came from comparing this observation with older data. Researchers went back to look at past light curves, records of starlight over time, from the same star, captured by other telescopes years before Webb. They discovered subtle anomalies in brightness dating back a decade, small fluctuations that now made sense. It appeared that the planet's death march had been happening in slow motion for years, perhaps even centuries, and we just hadn't understood what we were seeing. Webb's real-time clarity gave us the missing piece, turning those old mystery blips into part of a coherent, tragic narrative. In light of all this, future missions are now being designed with this kind of planetary death in mind. New instruments will prioritize long-term monitoring of planetary systems that show signs of orbital decay. Space agencies are even considering collaborative missions, combining the sharpness of space telescopes like Webb with the flexibility of Earth-based observatories like the Extremely Large Telescope (ELT), which will come online later this decade. Together, they'll form a planetary watch network, an early warning system to catch more of these events before they happen or while they're unfolding. And while Webb's primary mission is focused on the early universe, the fact that it captured something so dramatic and local, within our own galactic neighborhood, shows its incredible versatility. From probing the first galaxies to watching a planet perish, Webb has truly become the eye of humanity in the cosmos. Every week, it's unveiling secrets we never imagined, and this particular observation will likely remain one of the most unforgettable. Ultimately, the death of this distant planet was more than just an astronomical footnote, it was a revelation. A stark reminder that even the mightiest worlds can fall, and that space is not a place of stillness but of constant, often violent, transformation. And yet, in capturing that transformation, the James Webb Space Telescope has given us something precious: understanding. Through destruction we've gained insight. Through loss we found knowledge. And in watching a planet vanish, we've taken another small step toward comprehending our vast, mysterious universe.